okay, so we've been talking to geeks, and geeks know what you mean when you say 12 words. But every time up until I started studying the actual encryption, you said 12 words, I was like, no idea what the heck you're talking about. So I'm going to try and explain the 12 words. Okay? So when you get your phone, right, you go online to your Clear store, you purchase your phone, you're going to get a box in the mail. First of all, you didn't put in that's the biggest off-grid thing right off the bat is you're not walking into Verizon and they're not saying, do you have an ID, 2 forms of ID and proof of residency and all this stuff. Why are they doing that? The other day I had this little epiphany. It was like, okay, they're doing that in my head, I always walked in there like, oh, the government's making it. I have to because the government needs to know who I am, yada, yada, yada. And what occurred to me the other day, no, they're doing that because they need to be able to sell that this phone is you and that all the data off it that I'm getting is legitimate, and that makes the value of your data go through the roof. However, you go buy a burner phone, nobody gives a crap about the data on a burner phone, right? And so it's kind of like you guys have figured out how to take the blockchain encryption that happens, which I understand you get a Bitcoin wallet of some sort. They give you your 12 keywords and you set up a wallet, and that, holding those 12 keywords, you're the only person. So the 12 keywords that he's talking about is this thing that when you turn your phone on, it's generated by the phone hardware, not by Clear. You guys aren't saying, okay, this is your ID, but the phone hardware is saying this is the ID that you get.
And those are unique to every...
Clear does not get access to those. Clear is not told that this phone is you or anything related to it. There's no connection. It was just a product that came in the mail. Now it is 100% decentralized, all you.
Yeah, so just for the geeks out there, that key is generated with libsodium.
Libsodium?
Libsodium.
Libsodium, okay. Yeah. That's a service, some open source thing?
Libsodium is the foremost open source crypto library in the world. It's used in hundreds of
So that's a good
crypto
thing.
blockchain.
Libsodium.
Libsodium is a really good thing.
Awesome.
And so normal random number generators are not necessarily random. They're just pseudo-random. But Libsodium does the best job that you can do with generating random numbers. And so we generate that. That key gets encrypted with a 3072 RSA key that exists only on the phone.
I'm going to nod like I know what that means.
They
will, but I don't.
In order to decrypt that key, you have to have fingerprinted within the last 5 minutes, right, from a biometric perspective. Once that key gets decrypted, we use it to derive a key, and then we immediately remove it from memory and zero out the memory where that key was stored. And then this key gets treated as the one that derives all your other keys. Okay.
That should be the core of what your real question is.
Right. This is the skeptics right here. How could it be off-grid? A, you don't ever give me your identification when I send you the phone. I being Clear, right?
So not only that, but you actually scan a QR code and you actually take total ownership of the hardware, which most hardware manufacturers never even do. When they retain ownership of the hardware, there's certain services that they can actually do and or rights legally from data that they can actually provide. This is just the opposite.
Yep, you literally legally own your phone.
So in addition to legally owning your phone, you legally own your data, and you as a parent can actually get those 12 words. And then when you get a child, even before you get the 12 words for the child, you can use a derived key from you as the parent to actually create your child's profile and link that to your world. So literally the apps, the different settings, I'll pull up and actually show you exactly in my world. So you can see all of my family members. And then I can drill into one of them and actually see their different devices, their different applications, and where they want to go online, etc., in real time. There's other things inside of this application called Clear Life, which you'll be able to manage much, much more in the future. But this Clear Life application is tied to the basis and all permissions built into these phones. So imagine a parent with a child relationship that's built in, but then that child actually turns 18 and gets their own primary master private key and then goes and starts their world. And then imagine what happens when they actually die or you die. Does that data go back into the future? Because we literally are in physical lives today, but digital lives here. And the combination of physical and digital together, coming together with what we call Clear Life, literally is the future of how technology for the new millennium will literally be built, will literally be derived, will literally be shared, will literally be gained. And when we talk about Clear GM, think about it this way, it's blocking the whole existing internet that we have and allowing only the good based upon where you want to go in real time. using machine learning and artificial intelligence. But ultimately, that's riding on the existing internet that we all call internet, which is all broken.
Corrupt and
so the same type of key management that we talked about from an individual to an individual will actually be the same type of key management for the future of the internet as the next generations will come to know it. So hopefully this answered your questions. Conrad, is there anything else you want to bring up as points or important notes?
One of the emails I read, someone was accusing us of still being in the middle of everything and being central to everything. The decentralized storage, we don't have the keys for that. We don't have the keys for the password manager. We don't have the keys to even manage your gateway management policies. I mean, literally, even I, who architected the entire system, who has the closest thing to God powers, I can do nothing with any of your stuff, right? Support has to remote control your phone.
Right, and anybody that's gone through the process of setting it up would know that, right? Because they've done all of, they're not giving you
there has to be an element of, one, faith, yeah, I could do it. But ultimately, what Conrad's talking about, the way this is architected, we've architected, that's why we call it Clear Center, which has been building this for 10 years plus. Clear Center, there's no center to it. It's intelligently designed by no central individual, organization, or government can actually manage these phones in the future. But think about it. Some of these pieces are around how does blockchain actually get involved? And
I did want to talk about that.
Yeah, because I don't quite get that yet.
Yeah.
Can I ask a question?
Yeah, go ahead.
There, just to wrap up in my mind, you've mentioned private keys, public keys, and derived keys. Can you quickly define each of those? And you've mentioned pairwise keys.
Yeah, so
Connor, before you do that,
yeah.
give a little precursor, say, okay, let's just, we've talked about these three things, but let's define them.
Okay, so we've been talking about lots of different kinds of keys floating around, and so I just want to be clear about the different kinds of keys. So with the cryptography that we use, you have a key pair which is made up of a public key and a secret key. The way that the mathematics works out is that if you have a public key, I can encrypt something for your public key in such a way that the only way to decrypt it is if you have the corresponding secret key. And so the public secret key pair allow you to message securely back and forth. The master private key is what we call a seed, and a seed can be used to generate a pair of keys or a key pair. So a seed gets you a public and a private key, or a public and a secret key. Using a secret key plus a context, you can derive a new seed, which gets you a new public and private key pair. And you could take that private key plus a new context and derive yet another seed, and that can go on forever.
So you could have like 8 levels of public-private.
You can have an infinite number of levels. So essentially...
My point, I guess what I'm trying to wrap my head around is that like levels of encryption that someone would have to break? Is that why you would do that or no?
Each key and each encryption is independent, and you can't go back on the hierarchy, right, of keys. But, from the perspective of if you have your master secret key and you're deriving, key 1, which derives key 2, which derives key 3, if key 3 got compromised, right, and then you say, okay, well, I'll just use key 2 to derive a new key 3, right? So key 2, they never got to key 2 in the first place, right, because key 2 didn't get compromised. And they're 2 steps away from key 0, right? And so from that sense, right, when you use derived keys with pre-rotation, the way that we've done it, it really is bulletproof.
Like it's unbreakable.
Right, the only way to compromise that system is to be in the physical location when the key was first created and to be privy to that key. Or if someone got your 12 words on a piece of paper, right? But then that's once again being at a specific location in space and time where the key is present. There's none of this where you can look up digitally after the fact and get hold of it.
Unless I stored that somewhere that it could be accessed online, then that's on me.
Yeah, like people taking a picture and uploading it to Google Drive.
I'm going to put it on Google Drive or my iCloud or whatever and give everybody access.
So your private key, your secret key are those 12 words.
That's right.
And then where does the public key come from?
So those 12 words never generate a public key. So the original 12 words that you enter, that's a seed for an original key pair. We use that key pair to generate another key pair, which we treat as your master key pair. And so that's to distance you one step away from the actual 12 words in the beginning. And so that's the very first step that happens. And so that first derived key is then used as the source for all other derived keys.
And that's then known as your master key.
And so that would be your master key pair.
And then where does the public key that you referenced come from?
So when you have a seed and you create a public and a private key pair, that key pair exists on your phone, right?
Okay.
If you choose to share that public key with somebody, then you share it with somebody. And so, for example, if you have an app developer who develops an app, when he connects the app to get a derived key for his app, that app is going to get a derived key, and that developer is going to have access to see both the public and the private key part inside his app, right, that he developed. And so what he'll do then is he'll take that public key and upload it to his server. But he won't do that with the secret key, because the secret key is how he's going to authenticate you in the future, right? And so then instead of needing a username and a password, when you open the app, then automatically the app is going to send a request to the developer's API or whatever to get whatever information. And that request gets signed by the secret key. And that's how the app developer knows that you really are that public key. And so you as a user never have to worry about usernames and passwords again in a decentralized world. Everything can run on derived keys. And all you have to do is fingerprint to decrypt.
Because the phone and everything has been brought all the way back to the identity, the individual, then all of the key management communication. The internet gets easier. You can trust everybody. You know your stuff's safe. Like, it just...
Imagine a world where you can log into all of your online sites, applications, banking, you name it, from health, you name it, from medical, you name it, from any kind of ecosystem, insurance, all of it, if you need any of that stuff. And any kind of logins on the phone, and you always do it from your finger.
Right, so you have to have that biometric component that is part of the security. So other than somebody cutting off your finger.
We call it four-factor authentication. Something you have, a phone, something you do,
touch.
something you are, in a certain space and time. So it's literally, but there's no other third-party system that has those elements to them. You control and own all of them. And then you can actually regenerate your passwords of all these logins to crazy longer things that are more complicated, but you never have to remember them. The phone does all the work, and you are who you say you are always when you authenticate. Does that make sense?
Mm-hmm.